we are going to deal with stationary or standing waves, wave in organ pipes and string. Okay, we know that we have two kinds of organ pipe, that is either open organ pipe or closed organ pipe, and then in strings and sonometer. Yes or not? Sonometer we'll be dealing with. So the first question that was asked in BP 2013 is the difference between a resonating length is 31.5 centimeter in the resonance column. The wavelength produced is. Okay. First of all, in the resonance column, yes, in resonance column there is water field, yes, at one end is closed. So when I say there is, okay, let's see, when there is when we are calculating the fundamental frequency in case of closed organ pipe or resonating column is an example of closed organ pipe, yes or not? This always at the close end this node is formed, at close end always node is formed, and at the open end always what is formed? Anti node is formed. Okay, at the close end always node is formed, and at open end always anti node is formed. So the distance between the nearest node and anti node is always lambda by 4. Okay, lambda by 4. Suppose this is the length of resonating column L, so lambda by 4 is equal to L. Yes, lambda by 4 is equal to L. Therefore lambda is equal to 4L, or simply we can say that L is equal to lambda by 4. Are you getting it? This is in the fundamental frequency. Now for the next harmonic, this is first harmonic. Okay, next harmonic is like there will be this will be like this. Yes, so between one node to another node the distance is lambda by 2, and between node and anti-node the distance is lambda by 4. So total distance is lambda by 2 plus lambda by 4, that is lambda by 2 plus lambda by 4, which is your 3 lambda by 4. This is L2. Yes, this is first resonating length, this is the second resonating length. Are you getting it? When I subtract this, the difference between the resonating lengths L2 minus L1, that is 3 lambda by 4 minus lambda by 4, it will come 2 lambda by 4. This is L2 minus L1, or this is L2 minus L1, and this is equal to lambda by 2. So the difference, look at the difference between resonating length is how much? 31.5 centimeters. The resonating length difference is this one. This is 31.5 centimeter is equal to lambda by 2, or therefore lambda will be 2 into 31.5, or this is 63 centimeter. Are you getting it? This is quite easy. Yes, so we knew that, what we knew here, first point, lambda by 2 is equal to L2 minus L1, or lambda is equal to 2 times L2 minus L1. This is lambda. When we multiply it by f, this is lambda f is equal to 2f L2 minus L1. Lambda f means what? Velocity. Velocity of the sound in the string will be given by L2 minus velocity of sound in this resonating column will be given by L2 minus L1. Did you understand that? Okay, so this is the velocity of the sound. Second point, from here look here, L1 is lambda by 4 and L2 is 3 lambda by 4, which is 3 times lambda by 4 or not? So 3, and in place of lambda by 4 we can write L1. So L2 will be equal to 3L1. L2 will be equal to 3L1. That is, if first resonance is occurred at 31.5 centimeter, then second resonance will be occurred at 31.5 into 3 centimeter. Yes, this is odd multiple of first resonance. Then the third 5L1, fourth 7L1. In this way you can find the resonating lengths. First resonating length at L1, then second resonating length will be occurred as 3L1, third resonating length will be occurred as 5L1. In this way you can find the resonating lengths. Let's move to next question now. Question number next is your 20 vibrations is produced in 40 meter wire. 20 vibrations means 20 lambda. Yes or not? One vibration means 1 lambda. Two vibration means 2 lambda. Yes. So a number of vibrations, how many? 20 vibrations is produced in 40 meter wire. Then lambda is simply in 20 vibration 20 lambda will be produced, and 20 lambda will be produced in the 40 meter wire. So lambda will be equal to 40 divided by 20, which is your 2 meter. Option number B is the correct one. Let us move to next question now. Okay, see, look at this question. The question is, the string of length 0.4 meter, okay, and mass 10 power minus 2 kg is tightly clamped at ends. The tension in the string is 1.6 Newton. Identical wave pulse are produced at one end equal to at equal interval of time delta t. Identical pulse is produced. Okay, so the wave, okay, the value of delta t, which allows constructive interference between successive pulses. Okay, so we know that in the case of this one, whatever be its frequency should be equal to the frequency of next wave pulse. Yes or not? Frequency of next wave pulse. In that sense we can calculate the time. So first of all we'll calculate what will be the velocity. Okay, what will be the velocity of this one, okay, or what will be the frequency of this one. We can calculate the frequency of this one, and we'll make equal to the frequency of that one. Then it will be the our answer, f1 equal to f2. Yes, nearly equal frequencies, so it must not give beats. Yes, nearly equal frequencies should merge with each other. So what will be the frequency of first one? Frequency of first one in the case of string will be 1 by 2L root under T by mu. Okay, that is 1 by 2L, and it is T tension is your 1.6 Newton, and then we have mu, mass per unit length. Mass is 10 power minus 2, length is 0.4. So it is 1 by 2, L is 0.4, and here this will be 16. Yes, it's 1.6. So on calculating this all the things, it will come as 64 nearly. So it is 2 into 0.4, and this is 8. So 8 divided by 4 to the 0.4 into 2. So it will be how much? Multiply it, 0.4 into 2. So this will be 4 to the 8. So it is 0.8. Yes, so it is 0.8. So it will be cancellizing it for 10 times. So answer is frequency is 10. So frequency of first one should be equal to the frequency of second one, correct? So this is F1 equal to F2, or this is 2L by frequency is 2 V by 2L in the case of string is equal to 10. So we are set to find what? Time. Yes. Okay, let us say frequency. Both frequencies are equal, na? So F1 equal to F2. I am putting F1 over here, F1, and this F2 is 10, that is found over here. So time is 1 by T is equal to 10. This is time minimum. Okay, time is equal to 1 by 10, that is 0.1 second. 0.1 second is option number B. Option number B is the correct one. F1 must be equal to F2 na, in the case of constructive interference, and the phase also should be same. I am assuming that they are in the same phase. Okay, because here we in question they are not discussing about the phase. We can find frequency, so F1 equal to F2. So one necessary condition is F1 must be nearly equal to F2, that is matching. Okay, so 0.1 seconds. Are you getting this? Okay, so option number B is the correct one. Look at this question. This question is actually quite complicated type. Try to understand this. The frequency of sonometer wire is 1000 Hz. When the weight producing tension are completely immersed in the water, the frequency become 80 Hz. Yes, frequency in air is 100 Hz. Okay, frequency in the air is 100 Hz, and frequency in water is 80 Hz, and frequency in the certain liquid FL is 60 Hz. Yes, when the weight producing weight producing tension are immersed in different liquids, the frequency changes. This means what? Suppose this may not be the correct, but assumption. Okay, suppose this is the string. Okay, this is a sonometer wire, suppose, and with the sonometer wire one load is here, M. This M is over here. This M is first in air, then in second it is immersed in water, completely immersed in water, and in the other case it is immersed in the liquid. Immersed in the liquid. Are you getting it? First is in air. So in a different thing, when they are immersing, frequency is changing, and the question is asking what is the mu, what is the rho of this liquid, rho of liquid. This is water, so there is rho of water. Okay, this is the substance which is immersed in liquid and water, so I am supposing the rho of this mass is rho solid. There also this is rho solid. Yes, are you getting? Okay, when it was hanging in the air, this mass, this was producing this was mg. Yes, this was mg, and when mass per unit length of the sonometer wire is neglected or not neglected, whatever be the condition, let's see, this is mass, then tension produced is here. Yes or not? What is the tension? The tension is equal to mg in this case. So normal formula for the frequency, or simply okay, frequency is, what is the formula? 1 by 2L root under T by mu. Are you getting it? Everything is kept constant here. Suppose 2L is kept constant, that is L is always constant over here. Mass per unit length of the sonometer is also constant over there. Okay, and what are you seeing is the difference is tension. Yes, tension, because here in air what tension is working in water, what amount of tension is acting over here is different. T dash, this T double dash is different, yes or no, because of density of the because of varying density of the air, water and liquid. So we can see that frequency is directly proportional to root under tension. Yes, frequency is directly proportional to root under tension, and tension is equal to mg. Tension is equal to mg. Now in water tension is mg minus this of thrust of water, that is acting upward. So this is mg minus of thrust of water is given by v, density of water, and g. Are you getting it? When I break this mass, this is volume into density of the substance. Yes, so density of solid into gravity minus v, density of water into gravity. So Vg is